Hello, welcome to HandLab Chapter 1 Video 4. This video will introduce you to the Polhemus
Fastrak
motion tracking system. This system is very old, but it's pretty good and it's small and portable, and it's really useful for taking outside of the lab into public science events or anywhere else where it's a little bit awkward to get a good quality system. The Polhemus
Fastrak
can record up to 4 channels of motion of any kind of thing at up to 120 Hz. Let's take a look. Here is the big Polhemus power pack. Keep it away from everything else because there's a lot of electrical noise here. And the power plugs into the back panel of the main Polhemus unit. This is a 30-year-old piece of equipment, so do be careful. On the back panel you have the power cable and the data output cable labelled RS232, and that goes to the laptop. And on the front panel there's one large cable which goes to the transmitter, and 4 smaller cables, one for each of the motion trackers. And these 5 long cables are arranged very neatly, and they go around the lab in one bunch. You can have 4 trackers, each one attached to the body or objects or whatever else you want to track. In this case we've got one on the index finger and one on the thumb, and then there's 2 spare. With the
Fastrak
you have to choose how many trackers to record from. You can have 1 at 120 Hz or down to 4 at 30 Hz. This is a trade-off and depends on your experiment. The transmitter sends out signals in 3 different dimensions of 3 different frequencies for X, Y and Z, and the trackers pick up these signals and measure their relative strengths. Keep your cables tidy and arranged and together as much as possible. This reduces noise, but also it's just safer. It's really important for your experimental setup to have no metal or minimal metal, in particular iron or electrically conductive devices or radio frequencies or radioactive things, especially in the experimental area. So the chair, the table, the participants, they all need to have as much metal removed as possible. And it's a bit like a brain scanner in that sense. So you might ask your subjects and yourself to remove keys, coins, badges, mobile phones for sure, credit cards, anything which might be magnetic or magnetically sensitive, remove it from the experiment. Every room will have different sources of electromagnetic noise. In this room, it's the long cable guides at the back of the room that supply all the power and signals for the computers. So keep all your noisy stuff close to that, and then keep all your sensitive equipment far away as possible, with all the cables arranged in right angles from the power lines. Here's the final part of the system, the data collection on a computer. And we're using the serial port, and any computer that can take in a serial connection should be fine. The Patriot communicates via this RS232 or serial cable, which gives a very quick communication and very simple. But for the laptop we've had to use a PCIe adapter card, which slows down the communication to about 100 Hz. And this is only just usable for our experiments, so do be careful about the latency. Plug in the communications card, then secure the card and cables. And then plug the serial cable output into the RS232 port. And while you're watching me do this, I should say that from here on in, the Polhemus
Fastrak
is very picky about the exact order in which everything is done. So if something isn't working later on, turn it all off, make sure everything's plugged in, and then turn it all on again in exactly this order. When the laptop boots up, it gives an address to the adapter card, and that address will change if you unplug and re-plug the card, so don't touch it. If something doesn't work, turn it all off and turn it all on again. Turn on the switch at the front, there's some satisfying whirring noises, and then there's a light on the front panel that flashes, and when it stops flashing in about 5 seconds, it's ready. When MATLAB is booted up, check the computer is communicating with the stimuli. Usually in this experiment, one of the lights is on when you boot up. They're all connected by 5 color-coded cables at the back of this stimulus display board, and we can check they're all working using the grasplights.m test program, which turns them all on for 1 second and then off again. And we can just watch that again. And if these lights don't turn on, then turn everything off, check the cables, turn everything on again. The experiment is started by running the grasp2.m program. If it's working, it'll ask for an ID number. Then, if you want to do some practice trials, and if all that's working, a graph will come up. If you get to this stage, you know that the computer is communicating correctly with the tracker. At the start of each block of trials, we record the initial starting position of the subject's hand, so make sure it is in the right spot. The thumb tracker, number 1 in this case, is the one that is checked for this experiment, so make sure the thumb goes back to the same spot after each trial. When you're ready to start the experiment, press space to record this initial position. Finally, we're starting the experiment. You can start with 10 practice trials of the experiment. On each trial, the central LED lights up and the subject reaches towards and grasps it. Half the time, when you start moving towards the light, it will change location. In that case, you need to follow the light and grasp the new location of the light. If you don't move at all, then nothing will happen. The aim of this experiment is to update your reaching movement target location as quickly as possible. So we're looking to see how quickly people can change location once they're already reaching to a target. At the end of each trial, it's good etiquette to stay still with your hand holding onto the ball until the light goes off. This helps the analysis so that there is no movement after you've reached the target location. The good thing about analysing the data online and immediately is that you can check it's OK during recording. You can check the reaction times and have a look at the shape of the movements as well. Raw position data of the 2 channels are shown on the graph for X, Y and Z directions separately. And you're looking for relatively smooth, uninterrupted and nice looking data. So if your data are good and clean, there should be no sudden spiky movements in the data. The lines should look smooth, not changing position abruptly. And if everything's worked, then there's your experiment. At the end of your experiment, pack everything away very carefully, but not this quickly. Each tracker will cost about £500 and this equipment is very old. It still works perfectly though, and we're really quite fond of it, so please do be careful with this nice old equipment. That's all for now. So this was the small, old, relatively noisy Polhemus Patriot system that we use for collecting data outside the lab, for example in public science events, in difficult to get to places or for teaching. And if you like this video, you will love the next one, which is all about the new version of
FastTrak,
which is the Liberty, a much better, bigger, faster system that can do almost anything you want. Stay tuned.